Good morning students and welcome to our YouTube channel Gnan Manjari Modern School. In the previous video we have just started the new chapter, that was chapter number 12, that is fun with magnet. In that, first of all, we have seen what is magnet. So you know that anything that just attracts, no, that we have seen after the object just which is attracted by the magnet, anything that is attracted, that is the magnet in, okay. And then after we have seen what is magnet, after we have seen magnets are the object that attracts the other objects. Then after we have seen magnetic materials and non-magnetic materials. So first of all, what is magnetic materials? The materials which attracts the magnet is known as the magnetic materials, and the materials which does not attracts the other materials, that is known as the non-magnetic materials. And then after we have just discussed about the poles. So there are two poles, okay, there are two poles of magnet, poles of magnet. Okay, there are two types of pole, that is, first is north pole, and the second one is south pole, okay. So there are two types of the pole, north pole and the south pole, okay. So in that, what we have seen, attraction and the repulsion. So when the magnets are attract towards each other, that is when unlike poles are attracted towards each other, and like poles are repelled towards each other, okay, they are repelled toward each other. So that we have seen attraction and the repulsion. Up to here we have seen. And here, first of all, reading about the, okay, we have also seen, I forgot about the shapes of magnet. Shapes of magnet. So in that we have seen in the shape there are bar, disc, then after horseshoe, and another was cylindrical and ring. So these are some of the shapes of the magnet which we have seen in the previous video. Now from this video we will start with our new topic. So the new topic, that is magnet and direction. Let us see that, students. Magnet and direction. Let us see that is one very useful application of magnet is to find direction. Here we know that magnetic compass is used to find the direction. When you just place a magnetic compass over here, then you can know which direction is north, south, east, west, okay. Then after here Have you ever wondered how people found direction in earlier times? They found direction by looking at the movement of the sun during the daytime and the movement of the stars during the night time. Here in the earlier days there were no magnetic compass. So how they just find the direction? How just they find the direction? We know that here is north, south and east, and this side west. Okay, so how in the earlier days the people just find out the direction? What they do, they just see the position of the sun and they can know that we are going in this direction or this direction. How? Because we all know the sun will remain on the east only in the rising, and when sets down then it is west. So sun goes from here to here. So what rises in the east and set ups at the west. Okay, set down at the west. So from that they just know the direction, that this is this direction. Okay, and in the night time they see the stars and just find out the direction, that this direction is this and this direction is this. Okay, moving forward, they found direction by looking at the movement of the sun during the daytime and the movement of the stars during the night time. One very convenient method to find direction is using a magnet. Let us see that there is an activity given over here, that is to show that a freely suspended magnet always aligned itself in one direction. Materials needed: a bar magnet, a string, a ruler, a heavy book and a tabletop. Here method, that is tie one end of the string to the middle of the bar magnet, tie the other end of the string to the end of the other ruler, place the ruler at the edge of the table so that the magnet will with the string hangs loosely and the magnet is free to swing. Place a heavy book on the ruler so that it remains in place. You can see the figure is given, that is figure number A. Like that you have to put a magnet. Then after, swing the bar magnet gently and observe what happens. After the magnet has come to rest, swing it again. Repeat this step 3 to 5 times. Okay, discussion and conclusion: you will find the magnet swing a little and comes to the rest aligned in the same direction each time. Okay, when you just rotate the direction of the magnet and you will just remain steady, then it will come in its direction, that is north and south direction. Okay, moving further, here earth magnetism. Here we will first then talk about the earth magnetism. Let us see that earth magnetism. Earth magnetism. So here you can see first of all the figure of the earth magnetism. Here you can see there is a globe like this. Okay, and here is the south and here is the north, a bar magnet. Okay, because here it is a north pole, here it is an axis, here it is a north pole and here it is a south pole. Okay, so here the lines, magnetic lines will just go like this. It will go from north to the south like this, over this side also. okay, like this, it will travel towards this, okay. This is the earth magnetism. Okay, let us read which is given. To understand why a freely suspended magnet always aligns in the same direction, we need to take into account that earth magnetism. The earth acts like a giant bar magnet. The magnetic influence of the earth aligns all the magnets on the earth is the north-south direction. A freely suspended magnet comes rest to the rest in that is very closely to the earth north-south direction. This property of magnet can be used for finding directions. Okay, here first of all you have a doubt like me over here, that here it is north pole and it is over here south, here it is south pole and here it is north. We have already seen that the unlike poles attract to each other. North pole will not attract to each other, it will repel to each other. So north south and south north, they will attract to each other. So here it is unlike poles, and so you can find out the direction. Okay students, moving forward, that is magnetic compass. Here it is a magnetic compass. Let us see an instrument that is used a magnet to find direction in a magnetic compass. Here a magnetic compass have been in use for thousands of years. A magnetic compass can be used during day, night and also in the cloudy weather. Here A. Rotate the compass till the north tip of the needle points exactly to the north, marking at the compass dial. And now read your direction. You are facing towards west. North is somewhat towards your right and east is somewhat towards your back. From this, like this, you can find out the direction. Okay, so first of all, what is magnetic compass? Let's just write down in the board. Here magnetic compass that is an instrument that uses a magnet to find direction is called a magnetic compass. Magnetic compass. Okay, it is known as the magnetic compass. Here, moving further, a standard magnetic compass contains a freely rotating magnetic needle. This needle always aligns itself approximately in the north-south direction, and one tip of the needle is colored, generally red or black. Sometimes on half of the magnet it is colored. The freely rotating magnetic needle is placed in a round box in which the directions are marked. All we have to do is to rotate the box in such that the colored tip of the magnetic needle points to the mark N on the box, and all required direction can be read on the compass. By using a principle, a freely suspended magnet comes to the rest in the earth north-south direction. You can make your own magnetic compass. Here we know that we have seen the magnetic compass. Okay students, so if you want to see it again, I am just bringing a magnetic compass. Okay students, let me, if it is Okay, let me see that first of all. Okay students, here there was no magnetic compass, but I have bring a digital magnetic compass, that is our phone. Okay, so here you can see this like a magnetic compass is there. You can see as I am just moving this arrow which is pointed, which is north. Okay, you can see when I just adjust this to the north, yes, north is over here. Okay, okay, I just can't adjust, I think. Yes, here it is north, means on this side it is north, this side it is south, this side it is east, and this side it is west. Sorry, this side it is east and this side it is west. Okay, so this is a digital, in on all phones there are now available this magnetic compass. Here, take a look of it. See here, there is, here it rotates like here, there is a north. Okay, see here it goes move that side. So actually it is to be used like this, but I can't show you like this. Okay, so here I get a proper, see here, that side is north, that side is south on my back, and this side it is east, and that side it is west. Okay, so this is a magnetic compass. And moving forward students, that is the activity which is given over here on the page number 139, that activity is to be cutted. Okay students, so please cut that activity, and now we will just move further to the types of magnet, which is our new topic. So types of magnet. Types of magnet. Types of magnet. So let us see how many types of magnets are there. So here it is given. First one, that is temporary magnet. Temporary magnet. Second one, that is permanent magnet. Permanent magnet. And third one, that is electromagnets. 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 Okay. First one it is temporary magnet, second one it is permanent magnet, and third one it is electromagnet. So first of all, in this video we will just see the basic thing about it, and in detail we will see in the next video. Okay, so first of all, temporary magnet. So we have heard the word temporary, means for some time only, not more than it. Okay, so it is the temporary magnet. What? For some time it is magnet, after then its magnetism will be over. We have seen a needle, when we just rub that needle on the magnet, then we know that needle acts like a magnet. That is a temporary magnet. And then coming towards the permanent magnet. So what is permanent magnet? It can be stored, it have magnetism up for the long time. It is known as the permanent magnet. We have also heard the word permanent, that means for the long. Permanent means for when it is, okay, the magnet is there, up to that the magnetism is there, that is known as the permanent magnet. Then coming towards the electromagnet. So what is electromagnet? This is new for you. Okay, this is new for you. So if this is an iron piece, I just wound a wire over it. Okay, I just wound a wire over it. If this is an iron piece, then I just wound a wire over it, and then after I just give some voltage to it, then it will produce an electromagnet, that is electromagnetism. Okay, so these three types of magnets are there, but that we will study in detail. We have just seen the basic things about it. Okay, so first of all, in this video, what we have seen, okay, here first of all we have seen that is magnet and its direction. Magnet and direction, in that we have seen the magnet is used to find out the direction, as I have just shown you the magnetic compass in the mobile phone. Then after over here, then what next we have seen, there was an activity, and then after earth magnetism lines we have seen, as I have drawn on the board. Then after thirdly we have seen the magnetic compass. It is used from the thousands of years before. The magnetic compass is used to find out the direction. Then after thirdly we have seen that is types of magnets. In that we have seen the three types, that is temporary magnet, permanent magnet and electromagnet, but we haven't seen in detail. So in detail we will see in the next video. We have just told something the basic things about it only. So in your homework, what you just do is, in homework first question, that is how people found directions in earlier times. Okay, then after draw neat figure of earth magnetism Then after second question, that is what is magnetic compass? Is magnetic compass. Okay, so these three things you have to just do in your homework, and we will meet in the next video. Okay, bye students.